Hello, welcome to my channel. I am Ameya and we are discussing about time response specification problems. Today we are going to discuss a different type of problem where C of t is given and they are asking you to find damping ratio and natural frequency. Okay, so let us just take down what is given. C of t is equal to 1 plus 0.504 e raised to minus 307t minus 1.504 e raised to minus 2.18t. So this is basically given in time domain. Okay, and they are asking to find you a zeta and omega n which is in S domain. So first we need to convert from time domain to S domain. And what do we do for that? We basically take Laplace transform. So how do we take a Laplace transform? C of S is equal to 1 will be converted to 1 upon S, that is the Laplace transform formula, simple, and e raised to minus at will get converted into 1 upon S plus a in a simplest form for a Laplace. So this will change to 0.504, which is a constant, upon S. There is a minus, so that's why there will be plus 3.07, plus or minus minus, you will get 1.504, which is a constant, into S plus 2.18. Then what we do is we try to simplify this equation by a common denominator, and one more thing which is not given in the problem, you can assume R of S is equal to 1 by S, which is step input. Okay, I forgot to mention this in the problem, which is given R of S is equal to 1 by S. So we basically need to find C of S upon R of S. You will get the final equation as 6.6025 plus 6025 plus 1.73153, this is S, not 5, divide by S into S square plus 5.25 S plus 6.69. Okay, and then we substitute R of S as 1 upon S, so that will cancel out the S. So finally you get the equation as C of S is equal to some numerator, the same numerator, upon S square plus 5.25S plus 6.69, and this is what your characteristic equation is. So we will compare this with S square plus 2 zeta omega ns plus omega n square, and by simple comparison you can find omega n, which you will get somewhere around 2.58 radians per second, don't forget to write units, and you will get zeta as 1.041, and you can comment on damping, that is it's a over damped system. Okay, so this is how, if your C of t is given and it is asked for finding a damping ratio and natural frequency, first we have to convert into a Laplace transform. In Laplace transform you have to consider a transfer function C of s upon R of s, and we have to substitute that R of s to find the final value of C of s, and this value will be used to compare, denominator of that value will be used to compare with the characteristic equation, and then you get the final answer omega n upon omega n and zeta. Okay, so this is how you solve these types of problem. Let us meet in the next video for the next type of problem. If you like this content, do share my channel with your friends, subscribe my channel and check the playlist control systems, mechanical measurements and industrial automation. Thank you for joining.